जाओ खाना
Khan
पकड़ो.
had
Go.
any kids?
Go there. Go there. Good evening, sir. So I can't hear you. I can't hear you, sir. Yansh, close that.
सर के सामने
Hello. Hello, sir. We can't hear you.
Good evening, sir.
Hello, sir. We can't hear you.
Shantanu, you're muted.
Mute हो यार.
Hello, good evening. Good evening, everyone. Professor, I can't hear you.
Sir is in mute mode, I guess. Sir, I can't hear you.
I still can't hear you. I can see you talk. I think we can all see you talk, but we can't hear you.
Yeah,
Can you hear?
we can't hear you, sir.
Can you hear us, Professor?
Maybe not.
Good evening, sir. Good evening, sir. Good evening. We cannot hear you.
Yes, am I audible to everyone? Could you all hear me?
Yes, sir.
Okay,
Oh,
finally
finally.
we are back.
Yeah.
So
Good
I
evening,
have
sir.
good evening to everyone. Uh, Basically,
Good
I have
evening, sir.
shared few projects on data that is on Pandas, NumPy, and on Matplot. So we did with the NumPy, Pandas, and we did with the Matplot. So in the Matplot, we tried to do different form of data visualizations, right? So using the Matplot, what we are trying to do is that we're trying to implement different form of data visualization. So what are the different types of charts, or what are the different kinds of projections that we are trying to use? We'll be doing this things using the settings or using the data visualization tools that we are using. So the different data visualization tools that we'll be using, and using these tools we'll try to visualize the data through different charts or graphs. So let us go ahead and do few projects. I've already shared a project with all of you on your email with a data set. Could you pull up that particular project, the one that I have mailed you with the data set earlier today? Everyone? You all must be having the data set and the project that I mailed you today earlier. So you just pull up the data set and the project one. I'll tell you the project code that we will be doing right now. That is
Okay.
the one which I have forwarded you earlier, right?
So it
So
is
what
So is
like
it the
D3
linear
dot CS.
regression or using experiment?
it's using the data set. I'll tell you the project ID, which you need to pull up with the data set that I had mailed you today. So one is the EDA project 2. EDA project 2, it has got a data set D3. Do you see the data set D3.csv?
Yes, I can. I can, yes.
And in the data set D3, we got the serial number, height, weight, age, and the gender of that particular group, right? Now,
Yes, sir.
basically, we'll be doing the visualization based on the given data set. So
Okay.
basically, we'll be using all the three libraries. So the project, why I'm calling it as a project, because in this project, we're not using one, we are using all the three libraries, and all the three libraries playing a very, very important role. The first one is the NumPy library. Let me share the screen so that you can see the Google Colab window, right? It's very important, guys, that you understand the code and you are able to see what exactly we have done, right? So in this, I'll just increase the font size. It is coming very, let me zoom in, right? So we did with this particular project earlier. Do you remember the one that we have done using the sklearn matrix, where we use the all the three libraries? We are using NumPy, we are using pandas, we use the libpyplot, and we are also using the Seaborn. So all the three libraries that we are using here. Now, in this libraries, what we have used, what the sklearn library is doing here is splitting the data into two forms. So one is the test data and another one is the train data. So the percentage that it will, and then we store it in the data set. So the data set, if you do the head and tail command, we can see the first 10 rows on the last 10 rows. Then what we can do, we can do a plot between the hours and the scores, and then we can label it and we can show it with the tail command. And using the ilog function, we can identify which is the dependent variable, that is y, and the independent variable, that is x. And then we split the data set, that is on x train x test, y train y test, and we split it into a ratio of 80:20. That is 0.2. 0.2 means 80% will be your training data set and 20% will be your test data. Now, after splitting the data, you apply the linear regression model. So which particular model we are applying after splitting the data? After splitting the data, we apply the model linear regression that you can see in the code window, this one. Okay, and then we generate the slope intercept form of that particular linear regression model, and then we use the plt.scattered, and then we use the plt.grid, and then we do plt.show, and then we predict the model. So this is what is the output we get. So let me zoom in little bit, zoom out, so that you can see the model output for the linear regression that we have done using the different libraries such as NumPy, Pandas, Matplot, PyPlotlib, sklearn, and the Seaborn. And this is the best fit of the line, that is the intercept line that we are getting for the linear regression, which gives us the difference between the observed value and the expected value. And this is the called as the slope intercept form, because the equation of the straight line is equal to y is equal to mx plus c. So this is what we can see in the output screen, right? So this is the best fit line, and these are the predicted values that the model can predict us. So was this code clear to everyone, or how we did with the linear regression? Uh, Everyone has done this, and everyone has used the libraries that we were talking about. So these are the libraries that you need. I have already shared the screenshot of this code window, but when you run the code, when you execute the code, you should know what you are executing, what is the output, and you should go ahead and you should be able to interpret the output as per the libraries and the functions that you have used in your code window. So this is very, very important that one should know what libraries we are using and how these libraries will help us in understanding what type of output or what type of parameters. So if you run the code, you can see these are the outputs that it will fetch us, and we can have an idea about that. Now, today, what is the activity that I have provided you earlier is that we are about to do the data visualization using a box plot and the other parameters. So there are different parameters or different libraries that we are using. Now, I am talking about not the first EDA project. I'm talking about the second EDA project. The EDA I have given, I mailed you two projects, one using the d3.csv, and the other one is the simple linear regression, which uses the data.csv. So data.csv, which has the data set, are very different from the one that we have used. And the second one is basically the data set that you are supposed to import, and it has got the car, model, volume, then you have the weight, and then you have the carbon dioxide emissions. So these are the two different data sets that we are working with, and these are the models that we are trying to get into, and we are trying to predict what will be the outcome from these two different models that we have used for visualization purpose, right? I think Malik has joined. She's joining back now. Now, basically, guys, you all have done this one. And now please start doing the second project, the one that I have given you with the data set D3. I'll be also doing with you side by side. So let us go to a fresh code window, right? So I'm taking a fresh code window, and we'll do that particular project line by line, and I'll execute the project and all the three libraries that we have taken into consideration. So what are the libraries that we are working on with? We are working on with three different libraries. One is the NumPy, the second one is the Pandas, and the third one is the Matplotlib. So first what we do is that we try to import these three libraries. As you know, as per the standard convention, what we do, we import Pandas as PD or NumPy as NP, and we import matplotlib.plt. So everyone can see the screen that I'm sharing. Is it visible to everyone, guys?
Yes, sir.
Okay. So the first, what we are doing, I'm just making it a little bit bigger. I'm zooming so that everyone can see and understand what exactly we are doing in this particular project, because this project is important because all the libraries are included: Pandas, NumPy, and Matplot, right? And a data set is also involved. So which data set that we are working on with? The data set that we are working on here is d3.csv. So everyone, please download d3.csv file on your laptop or on your device, whichever you're using right now, because we need to import these data set using pandas.read. So there is a command that we need to provide to import the data set. So what is the command that we need to improvise to import the data set? It's pandas.pd, right? So what we are going to do is here is that we're going to import this data set. And how do we import the data set? I've shown you how to import the data set because you need to store it in some folder. Okay. And then how will you go ahead with this? You'll click on that box, right? And then you go to file upload. And from the file upload, you will select d3.csv. So so D3 is CSV will be used by your data set. So what happens is that the file that you upload, or the file that you're using on your device, will enable you to upload that data set. So everyone is doing the same activity that I'm showing you on the screen. Are we all on the same page, guys? Khalid, Aparna,
Yes,
Abdul,
sir.
Hassan, Sanjeevni.
Yes, sir.
Yes, sir.
Okay.
Yeah.
Okay. So
Oh,
we
sir,
are
I'm
all,
ready.
yes. Aparna, have you
I'm just
uploaded the
struggling
data
some
set?
problem with. Yeah, I
Okay. Okay.
downloaded it. D3, right, sir?
Okay. Okay. So take your time, guys. Not an issue. You all should be on the same page. That's very important. So how do I know that
Can you please zoom out?
can
Can you
you
please? Yeah. No, zoom out.
yes,
So we
Khalid?
uploaded the CSV file. What is your expectation? So we use the same code file that you sent as well?
The thing is that we need to use df is equal to pd.read.csv, and we need to get this command executed because we need to apply some visualization content. We want to draw some projections, some graphs based on this. So it's basically the content d3.csv, and then we go ahead
Yes, sir.
and we apply those visualization. So it's,
Content.
let us see d3.csv. Okay, it's there. Now I'll run the code so we can see the shape, or if you want to see the tail, you can go ahead and see the tail, the last 10 rows of that particular data set d3.csv. So we are all in the same page that we have been successfully able to upload the data set, right? Now we want to take the height and weight into two NumPy array, and then we want to apply a scattered plot. So what's the idea of doing this is that to get a scattered plot on the height and weight. Now, you know, height and weight are two different columns that you have in this particular data set that you have already imported, right? So you have to go ahead with the height, and then you have to go ahead with the weight. So heights and weight should be exactly the same that is in the data set which is written. If the spelling doesn't match or if there is any issues, it will definitely crop up, right? So what we are interested in getting those height and weight value. So it should be in a double quotes, otherwise what happens, it gives an error, right? So we'll put the height and weight in double quotes. So let us see whether
Sir,
that
can you zoom out? Can you zoom out?
I'll zoom out. Okay, I'll zoom out. Yes, I'm zooming it out. Can you see the code window, everyone? Everyone
Yes, we
can see
can.
the code window? Yes.
Yes, yes. You just be on this for 2 minutes.
Now we plot the scattered plot. So what we are targeting to do is that to generate a scatter plot and display the scatter plot based on the values that we have taken in the variable height and weights. So if we provide the scatter plot like this, we'll get the corresponding value of the height. I'll zoom in a little bit so that you can see the code in a one shot. So what we have done here, guys, we used three libraries. So what are the libraries? What are the libraries we are using? Here we are using the libraries such as Pandas, NumPy, and Matplot, PyPlot, and Matplot, PyPlot. And what we have done, we have imported these three libraries in the code window, right? So what we
Sir,
have done,
Matplot library is used for the visualization only, is it?
yes, it's used for visualizing the code. It's used for displaying the scattered plot or box plot that you will be using in your code, right? So we can use a scatter plot, or we can use different type of plots to visualize those plots. We use matplot, pyplot. that particular library. So this is the output that we'll get once we apply the library. Everyone can see the output. Is the output visible to everyone?
Just terminate other session. Sorry.
Sir, wait, just 2 minutes. Huh?
Okay, I'm waiting. No, not an issue. I'll wait.
So can you go up? I want to see the code.
Yes. I'll go up slightly.
Slightly, can you zoom?
I'll zoom in. I'll zoom the code in. Okay.
Yeah, please, just
Yeah,
Go
that is
down.
better.
You need to understand how we are using these three libraries: Pandas, NumPy, and Matplot, and how this code is helping us in visualizing the charts and the project.
उसके head और tail shape दिया है df dot head tail dot head tail bracket में tail df dot shape df dot shape ऐसे shape फिर नीचे df dot tail tail
Yes, Abdul, are you facing any challenge? Abdul, are you there?
Yes, sir.
Khalid, are you through with the code? Could you copy paste the screenshot on the chat box?
This is not dot x label. Not dot x label. Heights. Okay. Doesn't make any sense. Not dot x label. क्या problem है क्या?
Sir, can you go slightly down?
Yes, sure.
What is a df dot shape?
Plot dot figure. Okay. So it is a figure size, right, sir? 10 or 8?
Yes. The
Where?
size, if I reduce it, will be in a less.
Let's
If I go
width.
5, so it will be having the less. Take the less space and check the output. Become smaller.
Sir, can I just go a little bit up? So why my df dot shape is not coming? df shape is not.
Okay, sir.
It has become so small.
It's too much small. Okay.
So now we got only the scatter plot, right? With this.
Yes. With this, we got the scatter plot. With this, we all got the scatter plot, right? But we also want a box plot, right? We also want a box plot, or we also want a histogram. So how we can get that, right?
Yeah.
Everyone doing this line by line? Are you all getting it? Abdul, Khalid, are you getting it line by line? What exactly we are doing?
Yes, sir.
Sir, why we did not put 10 readings over here, because df dot head was 10 and df dot shape last time it was, and you removed it saying that you're considering all the readings, is it?
Yes, yes.
Df dot shape.
So if you do the shape, it will give you the dimension, number of rows and columns that is there in your data set, right?
Okay. Head means first 10 and shape means last 10. That's what it is.
Yes. Head is the first 10 rows and the tail means the last 10 rows.
So why you have put this height equal to df height dot values? Means you have assigned it and then you're plotting it with these heights, is it?
Okay, heights, it's a variable. Now, what from where is the height coming from? The height is coming from the data that we have imported, right? Suppose this is the data set I've imported.
Okay.
So the height is coming from the data sets. If I run the code, I can see the height. There is these values are the heights. So it is taking these value from these two columns. So that is why we are assigning to a variable, and that variable is plotted in the graph or uh, in the plots, whatever we are
In the
using. So
plot.
if you're using, so this plot x-axis you have the height and the y-axis you have the weight. And this is the XY scattered chart based on the height and weight that you have entered, right?
Yeah, the fixed size. Yeah. If you
Yes, this
increase
is the
10
fixed
by
size.
10, then the scatter size will be increased. Means the
Yes, yes,
plot size will increase, right, sir? Okay.
yes.
That's understood. X label, Y label, title, this is understood. So the last one, what you again said is df dot head 10, which was already mentioned at the top again.
Already mentioned, but it was not showing.
So
So
why
I
this
just
was
want
over
to,
here again?
because you can use the head and tail anywhere in the any section of the code to see what exactly are your column name and what value you are plotting in the chart.
Fair enough, sir. Understood. Understood.
Okay, now we go ahead slowly. Now we'll go ahead and we'll do the box plot. So the box plot will be based on which value? The box plot will be based on the value of the height and the weight that we have taken, right? So how do we go about with the box plot? So we need to add this particular code for the box plot. So we can get a box plot or we can get two different box plot, that is one for height and one for weight, where height and weight are taken from the data set d3.csv. So what we are getting? We are getting two different box plot, one for height and another one is for the weight. So this is the box plot we are getting for height and weight in a form of a subplots that we are using, especially this part of the box plot. So could you do this particular part of the box plot and see line by line, then you understand what exactly you are doing and what you are getting, right?
Okay.
Yes, Sanjeevni, are you doing this?
Yes, sir. I did it first. Now I'm doing box plot.
Box plot, do the box plot.
But sir, then where is weight over here? Because I got it.
Okay.
One is
So
both are heights, right?
yes, the first box plot that you have got, that is for which particular variable. The first box plot you have got is basically for weight, for the height one, and the second box plot that you have got is for the height. So I'll just reduce the size so that you can understand which one is for the height one and which one is for the weight. Now check the output. The first one is for the box plot is for the weight, and the second one with the height. So basically the first one is the height and the second. How do we know the first one is height? Because plt.boxplot, the first command that you see is the height, and plt.boxplot, the second command that you see is the weight. So that is how we can differentiate that the first one is the basically your height and the second one is your weight. And these two values are coming from the data set that we have taken, right?
Okay.
Yeah. Sir, can you just go up in the
Yes,
code
yes,
if you don't mind?
yes. And
So
there in the
now,
code.
1 to
yeah.
1.
Now, sir, so okay. Now this plot figure is for the size. Now plot dot subplot 121. How did you? Why this is 121? Can we have something else? Means how
Yes,
this
yes, yes.
number came?
That is the size of the
Sorry, sir.
sub.
I'm just asking stupid questions.
No,
But
no, no. It's very important that you know each line, why you have written and what is the purpose of writing. So that's the reason we are doing a project where we have so many libraries that we are using, right? So subplot is basically the size of the subplots that we are taking. So we have taken 121 or we taken a particular value. So what exactly this value will signify? So 121 is the basic the basic size that the subplot can come in. If you give less than that, the dimension doesn't match or you don't get the plot like this. So it should fit in the frame, no? Otherwise, what happened? It comes in the one single frame. You see, I've changed the value and what is the output? It is little bit changed. So we're getting the both the subplot in the one particular frame, right? So this is however subplot is making a lot of difference that we are using in our code, right?
Okay.
Actually, Professor, I have one comment.
Yes,
In
yes,
the
yes.
in the first module that we studied, the basics
Yes.
of Python, it was mentioned a number of times that comment, comments in code are extremely important. And it is actually in the exam, once we submit the code, we are supposed to have so much comments to be able to have the code as self-explanatory. I think
Yes.
this would have helped us understand this code here, because even you describe and explain, I still have to do my own research and try and find what is fixed size, what is subplot. It makes it harder, to be honest.
Okay, I'll give the comments. I'll give the comments. Taken your suggestions, Khalid. Very nice. So we'll give comments line by line what exactly it is doing, right? So the subplots basically providing us a plot for two different data or the two different columns. So I'm just giving my comments over here so that becomes self-explanatory to everyone, right? I'll put my comments. Provides subplots in a frame. That means in a single frame. In a single frame, we can have frame having more than one plots. So that is how what we are getting over here. We are getting two different subplots. That is in the single frame that we get the two different subplots, right? So that is how it is showing
Yeah.
us, right? So I think now it has become more self-explanatory to everyone, right? Now Suppose you want to get a histogram also. So you got a box plot and you got a scatter plot, right? You also want a histogram of height and weight. So how we can get a histogram of this height and weight, and how this histogram will help us to visualize the data, right? So I'll put the code here and then
Yeah.
I'll give the comments, right? So this is the histogram plots of two different data. So here we are using the fixed size. The fixed size is the size of the figure. So let me put a comment over here. The fixed size, it is the size of the figure, right? So what is the size of the figure? That can be identified by using the fixed size. So fixed size provides us with what? The fixed size is providing us with the size of the figure that we are using, right? Now, what we do here, not only the fixed size that we have given, that is the subplots, two subplots for histogram in one frame. So what does that will signify? Two subplots for histogram in one frame. So that is what it provides. So when I run the code and I'll show you the output. So you get two histogram. The first
Professor,
histogram is for the height, and the second histogram that you have got is for the weight. So when we giving the two subplots, so basically the first one is for the height. So I give a comment. The first histogram is for height, and the second histogram is for the weight. The second the second histogram is for the weight. Now we also provides the title. So title of the first histogram is histogram for height. The title for the second histogram is the histogram for weight. So I write it down in the comment. This provides.
Professor, I added the link in the chat with regards to the subplot. And
Okay,
this link is taken from W3 school. And it actually explains that the subplot accepts three parameters, which basically sets the row and the column, and then the sequence of the diagram. So when you say in your code subplot 121, is that by default taking it as first row, second column, or first column, second row, first diagram? How does that correlate with the W3 school description?
okay. I'll just let you know. Now here, when we use the subplot, Khalid, we are taking the three different parameters, right? So first is basically the row. The second one is basically the column. What you can do is that it depends on the figure that you're using. One row, two column, and this plot is the second plot. One row, two column, and this plot is the first plot. So how do we identify which row, which column, and which plot? So basically when we take 1, 2, 1, or 1, 2, 2, or 1, 2, 3. So 1, 2, 1 signifies the first row, the second column, and the plot is for the first one. If we write 1, 2, 2, that signifies the first row, the second column, and the plot is for the second one. If we write 1, 2, 3, so that signifies first row, second column, and the plot is for the third figure that we are looking into. So this is how we can divide it into 3 different dimensions. Is it clear now? Should I put it here in the comment? Okay, I'm putting it here in the comment. Wait. So,
Yeah, and also I just want to make it clear for my other colleagues as well that 122 can actually be 1 comma dot 2 1 comma 2 comma 1 as 3 different arguments, not just as 1 1 or 122, right?
yes, it's basically the first row. I'm writing here in the comment. It is the first row, and then after the first row, what you have the second column. First row, second column. That signifies the plot is the first plot, or one is that signifies one indicates first plot. And when we write this one, so it is the first row, and then we have in the first row we have the second column, and this plot signifies the second column, and one, two indicates second plot. Now I given the comment. Now it is become very clear what exactly it is doing and what output that we are getting for the first and the second plot, which is generated for the histogram. The first one for the height and the second one is for the weight. Is it clear to everyone? Are we all on same page in this regard?
Yes, sir, we are clear.
Okay. The next one is that we go ahead and we'll try to figure out the mean, standard deviation, and median that we have already done using a NumPy function. So could you do that? The mean height, the median for the height, and the mean standard deviation for the height. Could you do that?
Yeah.
So NP dot mean height, NP dot median, NP dot standard deviation. And also you can do the quantile one, that is Q1, the quantile Q2, and the quantile Q3. That is what you can do it over here. You can figure out in which quantile or which dimensions that you are providing. And the most important part is the correlation coefficient that you are generating. So here you generate a correlation between these values for Q1, Q2, and Q3.
Sir, in the code you have put print medium height and then you have put curly bracket. What is that for?
That is the syntax how we can print. We can just do a simple print rather than making this so complicated.
Yeah.
We can
Yeah,
just
we
write
can do that.
we can just write mean underscore height or mean underscore median underscore height or standard
Okay,
deviation underscore dev dot height.
okay, sir. Thank you.
So everyone is on the same page. So you're understanding how we are working with three different libraries with NumPy, Pandas, Matplot, and we are using different type of plots. What are the plots we are using? We made histogram, we made a subplots with a histogram, a subplot for a box plot, and then we did with a this different type of plots. Now the data that is coming from where? The data is coming from a CSV file, right? The data is coming from a CSV file that we are using in these different type of plots, right? It's very important that we know which libraries we are using, and in each library there is a lot of things there. There are a lot of functionalities there. There are a lot of projections and graphs are there. So each library is a dictionary among itself, right? So NumPy has got so many things. Pandas has got so many things. Matplot has got so many things. sklearn library has got so many things. SciPy has got so many things. But we need to use what exactly is needed as per our requirement. Okay. So we need to customize it and tailor it as per our requirement.
So mean, then mean, standard deviation, variance, and what?
And then the Q1, Q2, Q3. Q1 is quartile 1, Q2 is quartile 2, Q3 is quartile 3, percentile, and then IQR, that is the interquartile distance, that is Q3 minus Q1.
Still running.
So we are getting the mean height, the median height, the standard deviation of the height, Q1 value, Q3 value, the difference between the Q3 minus Q1 in the output. So you should be able to understand which libraries we are using, what are the functionalities of these libraries, and which particular functions that we are using in our project. So project is a data set which you're working on with, and you're using multiple libraries, and you're using the functionalities of these libraries in your code, right?
So there is one here, this Q1 height comma Q3 height and is equal to NP percentile height 25 comma 70. What is this, sir? 25 comma 75.
Okay, so 25 is Q1. I'll give a comment here. 25 percentile is basically the Q1 index, and 75
Okay.
is basically 75
Q3
is
index.
Q3.
I lost that yesterday. It told us.
Yes, yes. And this is IQR. I'll give a comment here. IQR is Q3 minus Q1.
And this is this. Okay. 1 comma 0 is for this. I have just made simple NP print. NP.
And here I give the comment correlation
Coefficient.
between height and weight. Okay.
Wow, this is not working. Okay.
So everyone understood how we are working with different libraries and the functionalities of these libraries that we are using and we are trying to incorporate in our code, right? Everyone is on the same page?
Yes, sir.
Very good.
Hmm.
Now we did with regression yesterday, right? Everyone did regression and the calculation part and how the regression analysis is manually calculated. We do with sklearn library that we have already seen and it's being executed, and you all can see how the sklearn library is working, right? Now today we'll do correlation. how correlation or covariance can be calculated manually, because even in regression we use correlation, that we find the r and r square value, right? So let us start with the correlation today. Okay, so I'll stop sharing this. We'll go back to the new window, and this is basically our correlation, right? So correlation coefficients that we are using, the type of correlations that we can go for with, and how this correlation coefficients providing us a very important insights, right? So is the screen visible to everyone? Could you all see the screen that I'm sharing?
Yeah.
So yesterday we did with the regression. Today we'll be doing with correlation. We'll see how is the correlation done manually and how important role does it plays, right? Now here, basically the first one is a correlation, which is a linear association between two random variables. So if you take a random variable x and you take a random variable y, so what we try to figure it out is a linear association between your random variable x and y, which gives us the correlation coefficient. So correlation coefficient is r, and the value of the correlation coefficient, it is between +1 to -1. So +1, if your correlation is near to +1 or 0.9 or something like that, it shows that there is a very strong association between your variable, that is your x and. If your correlation coefficient r is suppose minus 0.5, that shows that there is a negative correlation between the variable x and y. Negative correlation means the association. If x increase, the y will not increase proportionately. There will be a decrease in the value of y. So that shows that there is a negative correlation. So correlation is an association between the two variable x and y. If there is a positive correlation, that it shows that with increase in x, there is an increase in y. If there is a negative correlation, that shows if there is increase in x, there will be a decrease in y. So the correlation are broadly classified as positive correlation or a negative correlations, right? Is it clear?
Yeah. Yes, sir.
Okay. Now we move into a zero correlation. Zero correlation, if your correlation coefficient r is 0, that indicate that there is no relationship between the two variable, that is x and y. So if your x and y are two variable, then there lies no relationship between these variables. So a correlation of -1 indicates a negative correlation. A correlation of +1 indicates a perfect positive correlation. So +1 indicating a positive correlation, -1 indicates a negative correlation. So where negative means with the increase in x, there is no corresponding increase in the value of y. So here your correlation coefficient is what? Negative. It can be -0.5, -0.8, -0.9. If a correlation coefficient is positive, then it is +0.8, +0.9, something like that. A zero correlation indicates that there is no association between your x and y. So that's how your correlation works. So there are three types of correlation, and that is type 1, type 2, and type 3. So we'll look into what is a type 1, what is a type 2, and what is a type 3, right? So the type 1 is basically your correlation. As I've already discussed, it can be a positive correlation. It can be a negative correlation. There can be no correlation or association between the two variable x and y, or it can be a perfect correlation. So if your two related variables are such that when one increase or decrease, the other also decreases, that shows it's a positive. If two variables are such that when the one decreases, the other also increases, so that it shows that there is a negative correlation. And if there is no correlation, that means with the increase in x or y, there is no particular thing that both the variables are independent of each other. So there is no correlation in that particular scenario. Type 2. Type 2 basically correlation can be linear or non-linear. So when plotted on a graph, it tends to be perfect line. That is a linear correlation. When plotted on a graph, it is not a straight line. That is a non-linear correlation. So when plotted on a one graph, it tends to be a perfect straight line. And when plotted on another graph, then it is not a perfect straight line. So that is called as a non-linear. So we got a linear correlation and we also got a non-linear correlations, right? Now, these are the certain instances or graph, the XY scattered chart that you get when you are, it depends on what's your correlation coefficient R. Suppose if your correlation coefficient R is +1, your correlation XY scattered chart will be like this. If your correlation coefficient R is -1, then your XY scattered chart will be something in the case 2. If your correlation coefficient is 0, the third one will be your XY scattered chart. But if your correlation coefficient is zero 0.8, the fourth one will be your XY scattered chart. If your correlation coefficient is zero 0.2, the fifth one will be your XY scattered chart. And if there is no correlation and correlation coefficient is 0, the last one will be also very similar to the XY scattered chart that we would get in the output, right? So it all depends on the value of R or your correlation coefficient. Now, we also need to know what is a simple correlation, what is a multiple correlation, what is a partial correlation. So two independent, one dependent, more than one independent variable, one dependent variable, more than one independent variable, but only one independent variable is considered and the other dependent variable are considered constant. So we can have type 1, that is two independent and one dependent variable. We can have the multiple, that is one dependent and more than one independent variable. And then we can have a partial one. So two independent, one dependent variable, one dependent, more than one independent variable, one dependent variable and more than one independent variable, but only one independent variable is considered and other independent variable are considered to be constant. So these are the type 3 cases. So we have different type 1, type 2 and type 3. Now we come down to the method of studying the correlations and how we study or how we identify the correlation based on the method that we study. So the first method is the scattered diagram. The scattered diagram is basically, I've just shown you, it's an XY scattered chart where your correlation is taking between two different variable. The one variable is your X and the other one is your Y. The second one is your called as Karl-Pearson correlation coefficient method that we use. And the third one is the Spearman rank correlation. So we should know what type of correlation that we are using and for what particular value this particular correlation that we are using, and are we using this particular correlation for quantitative variable, are we using for qualitative variables. If we use a rank correlation, that means it's a Spearman correlation coefficient R. But if it is a Karl-Pearson coefficient for correlation method that we are using, so there's a different method for calculating a Karl-Pearson correlation and Spearman rank correlation, right? So a strong relationship, a strong correlation coefficient R. For example, if you take a drug A and if you take a drug B, and if you look into the symptoms or the index linked with the drug A or the drug B, the points that are clustered closely around the line, that shows a very strong correlation. So what are the points that are clustered around a particular line, showing a very strong correlation? So the line is a good predictor that it showed is a good fit with the data. The more the spread out the point, the weaker the correlation. The more closely packed at the point, the more is the correlation. And we have seen how correlation is related to your regression, right? So yesterday only I have explained the regression analysis, and in also regression we see R and R square, where the correlation plays a very important role, right? So a strong or a linear relationship or a fit. So coefficient of correlation. The coefficient of correlation can be yours Karl's Pearson correlation, where we use R, or we can use Spearman correlation, where also we can use R. So we can measure the strength of the linear relationship between two variables. So if we take a variable X and we take a variable Y, so we can go ahead and we can measure or we can find out what is the strength of the linear relationship between these two variables, whether it is weak or whether it is very strong, whether it lies between -1 or +1, what is the magnitude of the correlation and what is the direction of the correlation. That has to be very, very clear, and it should be clearly identified if we use the coefficient of correlation. So coefficient of correlation provides us with the measure of the strength of the linear relationship between the two variables that we have taken. One is X and one is Y, which provides us with the covariance of the variable divided by their sample standard deviation. Now R lies between -1 and +1, and +1 signifies positive linear correlation, -1 or near to -1 signifies a linear negative correlation. Now, please write down, this is a very, very important formula. We'll see some numericals based on correlation, how we can manually, we know how to calculate correlation in Python with coefficient function using the NumPy or the pandas, but this is how we can calculate the Karl's Pearson correlation, and R is basically the Karl's Pearson correlation, where X and Y are the variable, the individual variable among whom that we are going to calculate the correlation. So these are the shared variable of X and Y, and this shared variable will help us to go ahead and calculate the correlation between these two variables X and Y. So strong correlation, I've already told you, anything between 0.7 and above, and anything below 0.7, that is 0.3 moderate, to 0.7 and below 0.3, it's a weak correlation, and 0 means no correlation and minus means negative correlation. So this is how we interpret the correlation between two variables, whether it is strong, moderate, weak, or there is no correlation. Now the coefficient of determination. So we use the coefficient of determination that lies between 0 to 1. So what is that we are using? We are using the coefficient of determination that lies between 0 to 1, and it is represented by what? It is represented by R square. So R square is basically the coefficient of determination. It is a measure how well the regression line represents the data. So the coefficient of determination is the measure that shows how well your regression will represents the data. So if the regression is good, and if there is a good cause effect relationship, and your independent variable has a significant impact on the dependent variable, so the determinant of coefficient or will be R squared, will be more than 0.8 or 0.9, which will be equal to 1, right? Now it is basically the measure that allows us to determine a certain very important prediction from a graph that we make, the XY scatter chart, the coefficient of determination which gives us the variation to other of the actual value from the observed value. So this is how your coefficient of determination R square we also use in regression or the linear association between X and Y. The strength of the association between two variables, that is X and Y, can be predicted. Coefficient of determination represents the percentage of the data that is close to the line. So R square, if it is 0.9, that is very, very significant. 0.8 is also very good. But if R square value is 0.5, 0.4, that shows that it shows a weak association between the variables. So linear relationship between X and Y by the regression equation is also represented by the correlation coefficient R and R square. Then the second very important correlation that we use is the Spearman rank correlation. So one, we have the Karl-Pearson correlation coefficient R, and the second one we have is basically is your Spearman rank correlation. So what is your Spearman correlation, and how is your Spearman correlation different from your Karl-Pearson correlation? So this is a method which determines the correlation when the data is not in a available in a numerical form. So when your data is not available in a numerical form, and the alternate method of ranking the data is using a Spearman rank correlation. So when the values of the two variables are converted to their ranks and their form, the correlation is obtained. So there what the correlation is obtained, and correlation is known as what? The correlation is known as the rank correlation. So when the data of the variable are converted to their rank and the correlation is obtained, the correlation is known as rank correlation, right? So how do we compute the rank correlation? So rank correlation has a formula which we calculate the actual rank given. The rank are not given, but the grades are given. And what we do, we rank those grades in the scale of 1 to 10 or 1 to 5, whatever the scaling method that you use. You rank them, and then you use the formula that is 1 by 6 summation di square divided by n square minus 1, where n is the sample size, d is the difference in the rank between the variable x and y that you have taken. So it signifies what? It signifies your correlation coefficient that you are using, and it signifies how your correlation coefficient can work on with. Now what we go ahead is that we'll be now looking into a few numericals that is based on correlation coefficient, and we see some worked out examples both for rank Pearson correlation and for Spearman correlation. So basically there are two different forms of correlation, and we'll see how these correlation playing a very, very important role. One is the Spearman rank correlation and another one is the Pearson rank correlation. So we'll look into these two different aspects. The correlation, which is very important in a case when we are working on different data sets, right? So let us go with covariance and correlation. So I'll just be sharing the details so that you can look into that particular aspects, and then we can work out with those examples that you can see. So let me go ahead and share the screen. So I'll stop sharing this. We'll go out and see some worked out examples on covariance and correlation. Is the screen visible to everyone? Should I zoom it a little bit? Yes. Are we all on same page? Sanjeevni, Aparna, Abdul, Khalid, everyone?
Yes, sir.
Hassan,
Yeah.
Hassan is there? Okay, no, he has not joined today. So correlation and covariance. So this is a bivariate where it's one of the very important statistical measurement. We know the relationship of the variance between the two variables. So how do we know the relationship of the variance between the two variable? That plays a very important role. So covariance indicates how two variables are related And it also helps us to know whether the two variable vary together or they change together, whether the change in the one variable impacting on the change with the other variable. So here is a formula to for a particular population to calculate a covariance. And the formula that we use to calculate covariance is x minus x bar into y minus y bar divided by n, where x is the x1, y1, x2, y2, x3, y3 are the measure for x and y, and x bar and y bar is the mean value. And what we try to figure it out is the difference or the deviation from the mean value, and n is the sample size. So this is a sample covariance, and this is for the population covariance that we see here in the screen, everyone. And then we go into the next very important. This is the same formula for calculating covariance for a given population sample, or calculating covariance for a using a standard formula that is provided. And this x1 and y1 are the samples data that we have taken into consideration. It can be x1, x2, x3, x4 up to x10, or it can be y1, y2, y3 up to y10, right? And x bar is basically the mean value, y bar is the mean value for the y, x bar is the mean value for the x, and n is the number of data values. So these are basically the measures that we are taking, and the formula for calculating the covariance between the sample and the population variance, right? So basically the sample variance and the population variance playing a very important role where we take the data set. So these data sets playing a very important role when we go ahead and we calculate the covariance between these two variables. So this covariance playing a very important role when we take the population covariance and when we take the sample covariance. Now, here is a one small question that arises, or we'll be discussing this case for calculating covariance. Now, you're given the two variable x and y, and in here the x is the economic growth in percentage and the y is the return in the percentage. Now, what we try to figure it out, we need to calculate the mean and we need to calculate the covariance. So what is given over here to us in the x1 is 2.1, y1 is 8, x2 is 2.5, y2 is 12, x3 is 4, y3 is 14, x4 is 3.6, y4 is 10. So these are the range of values which are given for x and y, and we need to have a positive or an inverse relationship between these values of x and y, based on which we are trying to calculate or figure out the correlation. So here is the economic growth: 2.1, 2.5, 4, and 3.6. That is x1, x2, x3, x4. And the return is y1, y2, y3, y4. That is 8, 12, 14, and 10. Now, the basic idea is to calculate the correlation, covariance, right? So we need to find out the value for x bar and y bar. That is basically the mean value for the x and y. So this is how we use the formula to calculate the mean value for x and to calculate the mean value for y. So we got the x bar here and we got the y bar here, where we are getting the mean value for x and y. So for x, we add all the sample x1, x2, x3, x4, the 2.1, 2.5, 4, and 3.6, and divide it by 4. So we get the x bar as 3.1 and we get the y bar as 11. So once we've got the value of x bar and y bar, now we plot it into the table, or why this table is needed as per the formula. So formula for calculating the covariance will use xi minus x bar, yi minus y bar. So we'll go ahead and we calculate xi minus x bar. and we calculate yi minus y bar. So we take the mean value of the individual x1, x2, x3, x4, and we subtract it with the mean value. So 2.1 subtracted from the mean, giving us the resultant value. Similarly, y1, y2, y3, y4 will be subtracted from their mean value. And these, once we substitute these values into the covariance formula, it gives or it determines the relationship between these economic growth parameters and the returns that we get. So 2.1, 2.5, 4, 3, 8, 12, 14, 10, and xi minus x bar gives the difference, yi minus y bar provides you the difference, and we substitute these into the formula so that we calculate the covariance like this. Are we all on same page in this regard? Why I'm
Yes,
writing
sir.
xi is minus 1, yi minus y bar is minus 3, xi minus x bar is 0.6, yi minus y bar is 1, xi minus x bar is 0.9, yi minus y bar is 3, xi minus x bar is 0.5, yi minus y bar is minus 1, and then we add, so we get the covariance as 1.533. Is this numerical clear to everyone? Are we all on same page, guys? The numerical is clear. So what we are calculating here, we are calculating the covariance, or we are calculating the covariance or the coefficient for the covariance that we are using. And how do we calculate? We put it into the formula, and once we put it into the formula, we get the value for the covariance coefficient that we have calculated, right? So this is how
Sir, can you
we
just
go.
go a bit up?
Okay, I'll go up.
No, down, down. Sir, what you have done is minus 1 into 3 is what means?
That
Excel.
is
You're
xi
multiplying
minus,
every row like this. No?
yes, because the formula
We do not
is
have
what?
to add the
No.
xi minus.
We have to use the formula, this one,
Uh-huh.
xi minus x bar into yi minus y bar. So we'll be multiplying x1 minus x bar, or the x mean from the x1 value, mean y minus y bar, the mean value, and then we have to multiply it. So that is what we are doing here in the solution. If you can see, it's you can find out, or you
Yeah,
can
formula.
figure it out in the equation, that we have been doing the same thing over here. So what we are trying to figure it out is that we are trying to find out the difference. Where here you can
Hmm.
see xi minus x
Yeah,
bar
we
to y minus y bar, and then we multiply it, and then we add it, and then we divide by n minus 1, where n is the sample size, n minus 1 is the degree of freedom. So once we do that, we get the covariance.
Oh,
Covariance.
because I was thinking we have to add xi minus x bar, add y minus y bar, and then multiply it.
No, first we have to find out the value of xi minus x bar. Then we have to find out the value of yi minus y bar. And then you have to multiply the value of xi minus x bar into yi
Individual.
minus
Okay.
y bar. Individual.
Okay.
So it will be for
Okay.
x1, it will be for y1, it will be for
Fine,
x2,
okay.
y2, x3, y3, x4, y4, and so on.
No, okay. Okay, I did it in this manner. What I did was I added xi minus x bar, I added y minus y bar, and then the total result I multiplied it and divided by n minus 1. So, okay, this is a
Yes.
better.
This is the way
Okay,
we need to do it so that we can
okay,
implement it accordingly, right?
okay. Thank you, sir. Thank you. Got it. Okay.
Now, we need to also find out the Karl-Pearson correlation. So what is the formula for calculating Karl-Pearson correlation? I've told you that we have got two different form of correlation. One is the Karl-Pearson correlation, and other one is the Spearman correlation. So we got two different form of correlation. One is the Spearman correlation, and
Yeah.
another one is the Pearson correlation. So in the Karl-Pearson correlation, what we try to figure it out, we try to figure out the linear coefficient. We try to figure it out, we try to figure out the linear coefficient. That is, 0 means there is no relation, 1 means there is a strong relationship, -1 there is a negative relationship. So this is the formula that we use. Now we do a solved example by applying this formula, how we can find out. Now here we have a solved example where we have the value of x as x1 is 4, x2 is 8, x3 is 12, x4 is 16. Y1 is 5, Y2 is 10, Y3 is 15, and Y4 is 20. What we try to find out here, we try to find out the correlation between x1, x2, x3, x4, and Y1, Y2, Y3, Y4. So these are the variables given. So we need to chalk out a particular table or tabulate it in this particular form. Why we are tabulating in this particular form? Because as per the formulas demand. So whatever is the formula for the Karl-Pearson correlation, we have to use that particular formula and we have to tabulate the value for x1, y1, x2, y2, x3, y3, x4, y4, and we need to find out the value of x square, y square, x dot y. So this is the formula that we need to use for determining the Karl-Pearson correlation. This is the formula that we need to use so that we can go ahead and we can find out the Karl-Pearson correlation, right?
Yeah.
Is it clear to everyone? Are we all on same page, guys? So we calculate the value of x square and then we calculate the value of y square. We calculate the value of x1 square, x2 square, x3 square, x4 square, y1 square, y2 square, y3 square, y4 square. We find out the summation of x, summation of y divided by n. So we get the mean x bar and y bar. And then we multiply x into y. So we get that value also. Why we are identifying these value? Because the formula is like this where we have to substitute these values, right? Since the formula is demanding like that, that is why we are doing it, right? So what we'll do, once we calculate the value, then we put this value into the equation like this. And then we calculate the formula of the linear correlation that we have. And so once we calculate the formula for the linear correlation, we'll get the value R of xy and the corresponding result. And we here is 4 into 600. So what is 4 here? 4 is the sample size. And what is 600? Summation x dot y. Why we are writing minus 40 into 50? 40 summation x into summation y. That is what the formula is. Why we are writing 4 root over 4 into 480? Because it's n into 4 summation x square. So that is 4 into 480 minus 40 square y summation x of whole square. Why we are writing 4 into 750? 4 is the sample size. 750 is summation y square and minus what? 50 whole square. 50 whole square is what? Summation y of whole square. That is 50 square. So once you plot it into this particular equation, you get the correlation coefficient value. That is R of xy, and you get the R, which is equal to 1, which shows that you're getting a very significant value on substituting. Is it clear?
Yes. Clear.
Sanjeevni, are you getting it? Abdul, are you getting it? Hassan and Khalid?
Yes, sir.
Very good.
Yes, sir.
So basically, we now know how we can go ahead and we can calculate a correlation coefficient R based on the value of x1, x2, x3, x4, y1, y2, y3, y4, x1 square, y1 square, x2, x3 square, x4 square, y1 square, y2 square, y3 square, y4 square, then x dot y, x dot x1 dot y, x2 dot y2, x3 dot y3, x4 dot y, and so on. And once we plot the value, we get the value of the correlation coefficient R, that is equal to 1, right? So this is how we solve. Now, if I give you another one, and if I tell you to calculate the correlation between x and y, can you do this one? Could you try this one?
Yes, sir.
So can everybody try this and share what exactly is the value that you're getting when you plot this value in the equation? Can everyone try this second numerical and plot the value in the equation and tell me what value you are getting once you are executing or once you're processing those values?
So the formula for correlation.
Yes, yes, yes. I'll share it. So here is the formula that goes. Let me share it. So can everybody see the formula that I'm sharing for covariance? Covariance we have done. The formula for correlation. This is for the correlation.
Sir, it's very big formula. uh, I really forget.
No, no, you will not forget. That's the reason you need to practice. So I'll give you some practice examples and I'll share the PDF also so that you can see the solved example and you can practice. Correlation and regression is very important. Very, very important.
Yes, sir. Yes, sir.
You cannot just ignore them, right? You have to be very, very fluent in understanding them.
Yes, sir.
And this is how where we apply these formula into the numerical. So you have to use x1, x2, x3, x4, and you need to go ahead and you need to apply these formula so that you get the x1, x2, x3, x4, y1, y2, y3, y4, where your x1 is 2.1, x2 is 2.5, x3 is 4, x4 is 3.6, y1 is 8, y2 is 12, y3 is 14, and y4 is 10, right? And then you need to see how this particular formula will fit in and what output or what outcome or what variable, what outcome that it will generate, right?
So can you guys again go to the formula? Sorry.
Yes. Yes, not an issue. You should know the formula very well. So otherwise you won't be able to substitute those values, right? In the numerator, you have summation xi dot yi minus summation xi into summation yi. In the denominator, you have root over n into summation xi whole square minus summation xi of whole square, where n is the number of sample and xyi and xi are the value of the x1, x2, x3, x4, or y1, y2, y3, y4 that you are taking into the into considerations, right? So once you put this value, you get the resultant output, right? Malik, are you getting it? Malik? Now this is your data set where you need to put the value. Let me show the data set. This is your data set where you have to make a table with those parameters that you see in the formula. Okay.
So can you show the
Yes,
table
yes, sure.
that of the solved example? That
Yes,
will
yes,
be faster.
yes, yes, yes. Sure, sure. So you have to use
Sorry.
That is better, I guess.
yes, yes.
Yeah, it is. We added for engineering. We had this for we had this. This is again that I'm doing it.
Yes, yes, it's just a revision what you did in your engineering, right?
Yeah. For MBA also we had.
Yes, MBA has, BTech has. My students are all BTech, MTech in data science. I teach BTech artificial intelligence and machine learning. My MTech students are also there. Even I got to one PhD students also. So all of them, they have to study statistics and probability. That's become very compulsory in the curriculum.
Sir, can you please again show the formula?
Sure, sure, not an issue. I'll just email the PDF to everyone so that you can have it with yourself, right?
Yes, sir. That is much better.
I'll mail the PDF with the
Yes.
solved examples, so you can refer the formula and you can practice also. I'll give some practice exercise also.
Yeah, right.
What you can do is that you can take a screenshot of the formula and put it in the chat box like this. Okay, I'm doing it. I'm putting the screenshot of the formula in the chat box so that everyone can refer it as and when needed, right? And this is the table that you need to create, guys. I'll also copy paste the formula for covariance.
So just show us the formula again because I'm getting mine.
Okay, okay. I'll put the formula.
8 plus 12, 20, 10, 20 plus 10, 30, 10, 44. So summation of n into y1 square. Oh, y square. So this is coming negative.
Yes,
The denominator.
yes, correlation can be negative also. It may not be positive
The
always.
square root.
Yes, it may come negative, not an issue at all. You can have a negative correlation. Means when the x is increasing, there is not decreasing, or it's not positively correlated.
So is it minus 0.149?
Yes.
Yeah.
Yes, yes.
Now we have to find the variance. No?
Yes, yes. So you got R. So you got R, and now you
That.
go find the value of R square. So this is the table, and you substitute, you find summation xi, summation yi, summation xi minus x bar, summation yi minus y bar, put it in the formula, then you get the value of R, which is the integration coefficient.
Okay.
The next thing that is very important that we all should know is rank correlation. That is called as the Spearman correlation, right? How to find out the rank correlation, right? So the rank correlation means we use SPSS and other statistical tools. We use SAS also to find out the rank correlation. Suppose there was a class test which was conducted in two subjects, maths and English, and you got the marks of the 10 student, how much they scored out of 100 in English and maths, right? So what you got, you all got the score of the 10 student, how much they got in two subjects, that is in English and maths. And then you use the procedure for ranking this scores. So basically the scores that you have got for the student in English and maths, how do you rank the scores of the student obtained in English and maths? So first we create two columns like this, one for English and one for maths. So we put the marks of all the 10 student in English, all the 10 student in maths. and we rank them. The highest marks in English is ranked as 1. So the student who's got 80 is ranked 1, and the highest marks in maths is 77, which is ranked as 1. The second highest marks in English or the second highest marks in maths is ranked as 2. The second highest marks in English 75. The second highest marks in maths is 70, which is ranked as 2. Then the third highest marks in English and the third highest marks in maths is ranked as number 3. Okay, accordingly. And the lowest marks is ranked as number 10. So we create a table with the rank of the marks obtained by the 10 student in the test on maths and English in a class. Now the students are ranked in this particular order, 1 to 10, right? 1 to 10 is the rank. And once you have ranked the student, we need to find out the difference. So to find out the difference, I'll copy paste this formula for the rank correlations, right? So this is, I'll just do a screenshot of this on your chat box, because this is what we'll be using in our numericals when you're supposed to solve a numerical based on rank correlations. That is basically your Spearman correlation. So in the Spearman correlation, we use this particular formula that is 1 minus summation di whole square divided by n into n square minus 1. So what we use? We use the formula 6 into di whole square divided by n into n square minus 1, where di is the difference in the paired rank of the number of cases. So what is the difference in the paired rank of the number of cases that we take into consideration? And we use the formula when they are tied in the rank. So what is the formula that we are using? We are using this formula which are tied with this rank. So how and in what way we calculate? We calculate the difference. Suppose marks in English, marks in maths, rank for the first student for the marks in English is 9. The rank for the first student for the marks in maths is 4. The difference in the rank 9 minus 4 is 5, and the square of the difference is 25. The marks of the second student in English is 75, in maths is 70. The rank for the second student in English out of 10 is 3. The rank for the second student out of 10 is 70 is 2. And the difference in the rank 3 minus 2 is 1. And the difference is 1. Similarly, we do it for the third, fourth, fifth, sixth, seventh, eighth, ninth, and 10th student, right? And what we find? We find the summation of di square. That is the last column. And we put it into the formula so that we get the Spearman rank correlation, which is 0.67. Are you getting it? How we are calculating the Spearman correlation and how it is different from your Karl-Pearson correlation, right? Are we all on same page?
Yes.
Yep.
Sir, what is the answer for the first question you have given? I got 0.14. Is it correct?
No, it's
For
not
the
0.14. It is coming as a -1. I think Aparna has given it in the chat box, right? Aparna, what is what? Minus
No, no,
point
I did not put it. Minus, yeah, minus
minus
0.149.
minus 0.149.
49. You are almost there, Abdul, I think. So you just missed the minus.
Could you all do the second one, the rank correlation, which I'm showing you here?
Yep.
I'll just copy paste the data sheet so it will become easy for you all guys to do this. Wait.
So you have to do this now.
Yes, yes. Do this one and use the formula that I have already put it in the chat box, right? And tell me what is the answer
6
you are getting for this rank correlation. This is for Spearman rank correlation. You'll get the tabulated result like this.
We are giving everything. Okay. So now we have to use this, or we have to give, you are giving me the question, or how it is?
How to solve this? Means you have to find the difference. I'm just giving you the question. You apply the formula and you calculate the rank correlation. So basically the rank is given and you need to identify what is the rank. I'll give you a few assignments and share the PDF for the Spearman correlation,
That's better.
Pearson correlation, and some assignments for you all to practice. Okay, for the when you come for the next class, you should have some examples and some practice exercise for both the correlation and covariance, right?
Mm-hmm. 59. Sir, can you go a bit down?
Yes, yes, sure, sure. I'll go down here, here. This is how you calculate the difference or the d square. So d square will be depend on the rank of the data that you have been provided.
Yes. D square is 54 already. So now will be 6 into 54 minus 10 into 10 square. This one. Yes. 6, 324, 200 minus 1 into 10. 90. 324. Minus 1. Only sir, one question. In this rank, no, when we have when you have given us a data further, we have to rearrange it, or we can keep the same thing. Like for example, we can rank it for the first rank. 80 is a first rank for the maths.
There are
And
two
76.
cases. Aparna, there will be two cases. Number one, you're only given the data, you're given the marks in first 10 subjects, right? And then you have to arrange those marks, right? That is for the first 10 subjects. So basically,
We have to arrange them according to the ranks.
you have to arrange according to the marks that you're getting. You have to arrange the data as per the marks obtained by the students, right? So the highest marks will have the rank one.
Yeah, okay, okay. Understood.
And
So rank
the
1
lowest
will be
mark,
first element will be 80.
yes.
Second, let us see the second will be 76. You have to rearrange, right? Sir?
Yes, yes, you have to rearrange the rank correlation. The person who's got the highest marks will have the rank 1. The person who's got the lowest marks will have the rank 10. Okay, so what we are doing is that we are getting the raw data and we are trying to arrange that data as per the rank provided. So whatever is the rank we are getting, no? So we are arranging those rank in the chronological order. That is either in the ascending order and we give the order as per the data that is provided, or the observation that is provided. So the highest observation will have a rank of 1, the lowest marks will have a rank of 10, like that.
Amen. So one more question. If both that, if there are two records, two data of the same rank, then
if the two
61,
data will have a, suppose you got the two data of the same rank, 61, 61, but what we need to do is that we need to avoid those repetitions. So so in case if the rank are same, no, so the difference will come 0. Aparna, if you have got 61, 61 same, so and if you do D2 minus D1, you'll get a 0, a big fat 0, the difference.
No. In let us say in maths, two students have same marks. So then the rank will be same, no sir? 5, or let us say.
We'll take the first rank for the first observation, and then we'll take the second rank for the second observation. If in maths, suppose two students have got the same marks, or suppose in English they have got the same marks. So, but since they're comparing this rank with the other subject, not with the same subject itself, now it is we have to subtract with the rank in the other English with maths. Suppose maths, the two students got 61, but the two students will not get 61 in English. They'll have a different marks, right? So we need to find the difference. So
Sir, can you show us the ranking that you have done? Can you show me the ranking what you have done?
Yes. This is how we have done the ranking. Can you see the ranking? This is what we have done. It depends on the score. 80 is rank as 1, and the 76 is rank as 2. And as the marks decreases, the last rank is 10 for English. Marks 40 is the last rank for maths. Okay, so as the marks are decreasing, the rank is also decreasing. Can you see the table?
See, but here, sir, no, 1 minute, sir. If you go down, you have put 6.5, 6.5 because 61, 61 is duplicated. See that?
Yes. 61 here, what we have is that we divided it. We divided the rank of that particular position. Here we have a 61, that is 6.5. Here we have a 61, that is 6.5. So we got a rank 5 up to rank 5. It's okay. It's very clear. But when we have a rank 6, we put it 6.5 here. Means it is divided. Means neither 6 nor 7. It's somewhere between that.
Okay, sir. Fair enough. Now understood. I was solving it, so I was thinking, where did I go wrong?
Yes. You should know. And even apart from Aparna's very interactive through and through, and Sanjeevni, Abdul also. Apart from that, Khalid is there. He's left the meeting or what? Khalid and Hassan, I don't see them. Okay. You three guys are very, very interactive and very nice to go through all the numericals and the process, and very inquisitive, and you also solve and practice. That is very important.
Sir, one more. Sorry, now when you're writing this, let us say 80 is 1. Okay.
Yes.
1 will be for English. So you put 1. Now 77 is 2. So that 2 is for
no, the highest marks in maths is 77. So the rank for maths is 1. The highest marks in English is 80. So the rank for maths is 80. 1. So now the difference of the rank for 80 and 70, it will be 0. It will be 0. Similarly, the rank for English 58 is 8. The rank for maths 59 is 8. And then the differences are also 0, as we are seeing here in this particular table. So we see the rank and we also see the difference. And what we want is that we want the sum of the square of the difference. Even we don't want the difference. We want the square of the sum of the difference, right? To put it in the formula. So I hope we are all on same page and you all understood it very, very well, right?
Yes, sir.
So what we did today, let me summarize. We did a lot of things, guys. We previous class we did with NumPy, Pandas, Matplot. We did a linear regression. We did linear regression with NumPy array. we did linear regression with pandas. Then we did two or three projects. The projects which combines all these libraries together. What are the libraries that we have done in the project? The libraries that we have done in the projects is NumPy, Pandas, Matplot, PyPlot, and sklearn, right? Sklearn.
Yeah.
Then what we have done? Then we did with correlation and their types. We did covariance. We did rank correlation, that is the Spearman correlation which you're doing now, and we did a Karl-Pearson correlation, right? So there are 7 things that we have done today, and all the things are very, very important. We did yesterday or in the previous class, we did regression and how mathematically we can calculate regression and how we can go about it, right? So everything that we have done is very important and it counts. Not only we have done it mathematically how it is done, we have also seen how it is done through libraries in Python, right?
Yeah.
So that is what we completed today, and in this particular week over, I'll share the PDF and the assignments that you need to practice for the rank correlation and for the Pearson Karl correlation. And the next class that we have it on coming Monday, right? That is on 23rd. We'll do probability, we'll do Bayes theorem, and we'll see how we can do few numericals on probability and application of the Bayes theorem there, right?
Okay. Okay, sir. Sure.
So are we all on same page? Abdul, Sanjeevni, and Aparna. Khalid will obviously join us next class.
Sir, the recording what you share with the email, it's not opening. It's asking for the permission.
I've given the permission to everyone, and even the recording is uploaded in the Artix, that is in the admin panel. If you go to the LMS, you will get the recording till the last class, Abdul. All the recordings are uploaded. I've checked it. Okay.
Okay.
Okay, sir.
Okay, sir.
Thanks.
This
Thank
PDF
you.
also you're sharing now, right, sir? For this question to do the practices.
Yes, I'll share the PDF for the correlation, that is for the rank correlation, Pearson correlation, and Spearman correlation, and the assignments that you need to go ahead and practice, right? Okay.
Okay, sir.
See you guys in the next class. Wonderful interacting with everyone. Bye bye. Nice.
Bye
Bye,
bye,
sir.
sir. Good night.
Bye bye.